Welcome to EXI Flow Measurement's 9th video in a series about the SFC3000 supervisory flow computer. In video 5 we created a basic turbine configuration. In this video we will look at the other basic configuration types and a few extra elements that are commonly used. As we saw in video 5, the configuration of the SFC3000 is centered around the hardware and stream type selection. The hardware selection is determined by the sensors and other peripherals to be connected. The stream type is determined by the meter type being used and whether it is gas or liquid to be measured. For this video we will assume that the hardware selection has already been made and now the software configuration is being created. Starting from the Windows software main menu, click Edit Offline. If your installed version has compatibility with more than one version, you will need to select the version of the firmware to create the correct configuration from the list shown. This can be found on the System Information page of the flow computer. The next dialog has a series of drop-down boxes to select the basic machine type and each stream type. It is worth mentioning at this point that once a stream has been created within a configuration, it cannot be deleted. So good practice is to create the first stream, then add one at a time later. Also, this is useful if the stream to be added duplicates an existing stream. More on this later. Leave the machine type as standard. For now, open the drop box for stream 1 and we see the available selections: gas turbine, ultrasonic, differential pressure and Coriolis, liquid turbine, ultrasonic, differential pressure, Coriolis and steam Coriolis. The basic configuration process for gas and liquid streams is the same, so we will just look at the gas version of each. Also, we will assume an understanding of the meter types. Maybe this can be covered in another video. Since we covered gas turbines in video 5, we will start on the gas ultrasonic stream. Select from the stream 1 drop box and click OK. Ultrasonic meters can be used in one of 3 modes depending on the model: frequency only, communication only, and communication with frequency, where communication can be a serial RS-232 or RS-485 or Ethernet. For this example we will assume serial RS-485 with frequency and use the serial port of the I/O board. Go to the Hardware tab and select an I/O board from the Dropbox list. Click on the image of the RJ45 serial port. This will bring up a dialog box on the serial port configuration section. From the Dropbox, select Modbus Master. The serial port parameters are now visible and can be set to match the meter. Click the Master tab type, choose an ultrasonic single from the Dropbox list. For the moment, only the Modbus ID will need to be changed to match the meter. The Modbus map will be selected in the background when the meter model is selected later in the stream information. On the left of the dialog, under Input, click Digital. Using the drop-down ID tree, expand the heading using the plus symbol and set frequency 1 and 2 to USM meter and monitor frequency. Worth noting at this point that the ID tree is filtered by various selections, mostly stream type. The same as in video 5, we can set a pressure and temperature sensor on the first heart loop and click OK. Now go to the Stream 1 tab. On the left, click the ultrasonic meter icon. In the Dropbox you will find a list of ultrasonic meters compatible with this version of firmware. This selection will configure the Modbus master map as mentioned earlier. Expand the meter specific details and various values specific to the selected meter type can be entered. In the Pulse Input tab we can configure how the frequency inputs are used and which input, serial or frequency, is primary. Now the pressure and temperature inputs can be added to the stream as we did in video 5 for the turbine configuration. So that is a gas ultrasonic stream in its very simplest form. A liquid ultrasonic would follow the same process. Now we will add another stream for a Coriolis meter. Click New Stream and a dialog will appear. This is the same list we saw when selecting the gas ultrasonic meter, but with an extra option at the bottom to duplicate an existing stream. Select gas Coriolis and click OK. Now we have stream 2 as gas Coriolis. Go back to the Hardware tab and add a second I/O board. When you bring up the I/O configuration dialog, you will notice the IG tree now includes items for Stream 2, filtered by a Coriolis meter. Set the serial port, frequency inputs, pressure and temperature inputs, as we did for the ultrasonic meter, using Stream 2 values. Return to the Stream 2 tab and click the gas Coriolis icon. As with the ultrasonic, we can now set up information about the meter. Select the model from the drop-down list. This selection will configure the register map from the Modbus master port. There are other meter specific details in the expandable section. On the pulse input tab, how the frequency input is used can be configured. Next, we will add a differential pressure meter. Click New Stream, select Gas DP and click OK. Go to the Hardware tab and add another I/O board. Then, looking at the ID tree for Stream 3, we can see the differential pressure value can come from one of up to 9 sensors, 3 high range, 3 mid range and 3 low range, as seen in the ID tree. In a moment we will see that the DP sensors can be used in 3 different configurations of range: high only, high and low, and high, mid and low. As each loop can have up to 3 sensors, we will select one of each type. Back in Stream 3, look at the gas DP section. Note the used transmitters shows high range, and on the left there is an icon for DP high. If we change the used transmitters to low, mid and high range, mid and low icons and data entry boxes for the changeover points appear. The sensor selection and alarm points are each configured in the same way as the stream pressure and temperature sensors, but be aware that you will need to turn off any settings before changing the used transmitters setting, otherwise you will get alarms for the unused sensor ranges. The measurement type selected specifies which meter type of differential pressure meter is being used, with type specific details in the tabs. If we expand the pipe and flow constants, this is where general values are entered, and then in the meter tabs, meter specific values can be entered. Now we have seen the 4 basic meter types for gas measurement systems. Probably the most common extra element is a gas chromatograph. These can be connected via the serial port or Ethernet port, although some consideration needs to be made for multi-master systems if using serial ports to allow clear time between requests. On the Hardware tab, add an Ethernet board and click on one of the upper 3 RJ45 serial ports. From the drop box, select Modbus Master. Enter serial port settings, then move to the Master tab. In the drop box there are a number of common and specific interfaces. For the moment we will select Chromat Daniel 2251. The SFC3000 can communicate with up to 2 GCs, A and B, selected within the stream later. You will need the Chromat Modbus ID number. Click OK. Go to the gas data on one of the streams and change Gas Select 1 to Chromatograph A. On the Normal tab in the base gases with the keypad value, min and max values. In the previous chapters we used the serial port. Now we can use Ethernet. Each Ethernet port can be used for a number of functions, including Modbus slaves, watch the next chapter, and Modbus masters, printers, web access and remote configuration. By default the Ethernet ports are disabled within the flowcomputer. You will need to enter the IP address and subnet mask details. Windows software port number for configuration action will be required over Ethernet. Each Ethernet port can have 4 Modbus slaves, 2 Modbus masters, and configured individually, as well as remote access and printers. For the meter connections, we use Modbus masters. If we want to connect a DCS or supervisory type system, then we can use a Modbus slave. Masters are fixed within the script. Slaves are freely configurable from tree of IDs filtered by selection made elsewhere. Drag and drop from the ID tree, double click first item and enter address. Can autofill the rest on the number of registers in each item. To create sections, double click to the left of the address. Two types of printers can be connected, serial and network. Serial dot matrix or thermal roll feed printers can be used on serial port 1 on the Ethernet board, which has RTS and CTS data flow control lines. On the Ethernet ports, normal office type network printers with FTP enabled can be used. Printing can be triggered by time, event, or manually from the front panel menu. Serial printers are configured within the serial port settings, but Ethernet printers will need to be enabled in the Ethernet port, and the reports to be printed and the actions to initiate printing are configured in the Printer tab. This has been a very brief overview of what is available within the SFC3000, but more in-depth training is available upon request through tailored training courses. Please see the EXI flow measurement website for more information and downloads via the contact page. Thank you for watching.